Hello guys and girls, ladies and gentlemen, and non-binary people. So far, we have covered 4 out of 5 main elements of programming, specifically data, operators, functions, and branching. And in this lesson, we will start talking about the last but not least element, loops. So let's get right to it. Before we get started, as usual, let's create a new file for this lesson. Now imagine we want to write code that prints hello world, so we do something like this. Alright, now what if, for whatever reason, we want to print hello world 5 times? Well, no problem, just copy paste this line of code 4 times, and voila. Now how about printing it 10 times? No problem either, just copy paste the code, and done. Okay, then how about 1,000 times? Well, that gets a bit tricky or rather a bit annoying. In addition, a good rule of thumb in programming is to avoid copy-paste as much as possible. Luckily, if there's one thing computers are exceedingly better at than humans, it's repeating the same stuff over and over again. We can tell the computer to repeat a certain set of instructions essentially as many times as we want by using loops. There are basically 2 types of loops, the for loop and the while loop. Both are interchangeable, meaning there is nothing you can do with one that you can't do with the other. However, one is generally preferred over the other in certain cases. In this lesson, we will cover the for loop. The for loop is generally preferred over the while loop when the number of repeats or iterations is either constant or easily calculable. For example, if we want to print hello world 100 times, the number of iterations is 100 and it is constant. Let's try doing that now. A for loop, similarly to functions, consists of a header and a body. The header of a for loop starts with the word for, followed by round brackets. Inside the brackets, we can specify up to 3 things separated by a semicolon. And the code that we want to be repeated goes inside the body of the loop defined by curly brackets. So this printf hello world will be repeated a certain number of times. To make this loop run 100 times, we can do something like this. And if we now run the code, it will print hello world 100 times. In case you don't trust me, you can change this 100 to something smaller, say 5, and run the code to see that hello world gets in fact printed 5 times. Alright, so let's look at the for loop header. As was mentioned before, a for loop header consists of 3 parts. The first part looks like variable declaration, which essentially it is. This variable is called counter, and its job is, well, count how many times the loop has been executed. Here we assign the counter 0, meaning counting will start from 0. The next part is the termination condition, meaning the loop will run as long as this condition is true, and will stop when this condition becomes false. So in our case, the loop will run if I is less than 5. Since the initial counter value is 0, and 0 is less than 5, this loop will run at least once. The last part is counter increment. This double plus is called the increment operator, and it increases the value of a variable by 1. So what happens here is I is assigned 0. Then the computer checks whether I is less than 5, and since 0 is in fact less than 5, the computer executes the code inside the body of the for loop. And when it's done, it will increment the counter by 1, making it equal 1, and then check if the counter is still less than 5. Since 1 is less than 5, the body of the for loop will be executed again. And then the counter will be incremented by 1 again and become 2. And since 2 is less than 5, the loop will run again. And it will keep running until I becomes 5, since 5 is not less than 5. So the loop will run when I is 0, 1, 2, 3, and 4, meaning 5 times in total. Now it's important to know that I does not have to start from 0. It doesn't have to be less than a certain value for the loop to continue, and it doesn't have to be increased by 1. This is just a basic example. Alright, so as I mentioned before, the job of a loop counter is to count how many times the code inside the loop has been executed. But that's not the only use case. A loop counter is just an int variable, and we can use it inside the loop just like any other variable. For instance, we can print it, something like this. Or like this, if you want the numbering to start from 1 and not 0. Now the counter does not have to go up by 1 either. For example, if we want to print all odd numbers starting from 1, we can do something like this. What this code does is it first adds 2 to the value of the variable I, and then assigns the result back to the variable I, meaning if I is 1, then this code will add 2 to 1, and then assign the result, which is 3, back to the variable I, so I becomes 3. Alright, so now if we print I inside the loop, we will get all odd numbers between 1 and 50. Or we could change the for loop like this, and get all numbers divisible by 3. And finally, instead of increasing the counter, we can decrease it. So if we want to say print all numbers from 10 to 1 inclusive, we assign 10 to the variable I, continue the loop while I is greater or equals 1, and decrease I by 1 at the end of each iteration. To decrease it by 1, we can use a decrement operator, which is 2 minus signs. And we get the numbers from 10 to 1 in the console. And of course, we can decrease I by more than 1, like this. Alright, now how about we use the for loop to do something a bit more meaningful? Specifically, let's write a function that checks if a number is prime or not. A prime number, as some of you might know, is an integer number greater than 1 that is only divisible by 1 and by itself. For example, 2 and 3 are prime numbers, while 4 is not, since it's fully divisible by 1, 2, and by itself. Alright, so our function will return 1 if the number is prime, and 0 if it's not. So the return type of the function should be int. Let's name our function, say, check prime. Here, since function names, just like variable names, cannot contain spaces, I capitalize the word prime to make the function name a bit more readable. Anyways, next, the function will take the number that we want to check as a parameter. Let's name it n. Alright, so the most straightforward approach that we can take to check if a number is prime is we can check if the number is fully divisible by any number between 2 inclusive and the number itself non-inclusive. To check if a number is fully divisible by another number, as some of you might remember, we can use the modulo operator. Alright, so we run a for loop, start the counter from 2, continue the loop while the counter is less than the number, and increment the counter by 1 at the end of each iteration. And inside the loop, we get the remainder of dividing the number by the counter, and if the remainder is equal 0, which means that the number is fully divisible, we return 0, which means that the number is not prime. Now, if the for loop ends and it turns out that n is not fully divisible by any number between 2 inclusive and the number itself non-inclusive, it means that the number is prime and the function should return 1. The question is, where in code do we do that? We do that outside the loop, meaning after this closing curly bracket. Alright, before we move on, let's look at what will happen if n is, say, 5. We set I to 2 and check if it's less than n, which is 5. 2 is less than 5, so we run the code inside the loop. Here we get the remainder of 5 over 2, which is 1. 1 is not equal 0, so we do not return 0. Increment I by 1, which makes it 3. The remainder of 5 over 3 is 2, so this return statement is ignored again, and I becomes 4. The remainder of 5 over 4 is 1, so we ignore this return statement again, and I becomes 5. 5 is not less than 5, so the loop terminates and the computer moves on to the next line of code after the loop, and returns 1, which means that 5 is a prime number, which it is. Now what if n is, say, 4? In this case, since the remainder of 4 over 2 is 0, the function returns 0, which means that 4 is not a prime number, and the loop does not continue since, as some of you might remember, return statements terminate the entire function. Alright, before we test this function, we need to add something else. See, integer numbers less than 2 cannot be prime, so before we run the loop, we should make sure that n is greater than 1, meaning if n is less or equals 1, the function should return 0, which means that n is not a prime number. Please note that if you have only one line of code in the body of an if block, you can omit the curly brackets for simplicity. And now let's scroll down to the main function, comment out the existing code, declare an int variable, ask the user to enter an integer number, take user input, and pass it to the checkPrime function. And if the function returns 1, we print that the number is prime. And otherwise, we print that the number is not prime. Alright, let's test it. Let's check 5. Our program says that 5 is prime, which is correct. It says that 10 is not prime, which is also correct. And it's also correct for 1, and for 3, Alright, now some of you might have noticed that the variable names that we use for the function parameter when declaring the function and when calling the function are the same. Both are named n, but they don't have to have the same name, meaning if I change the variable name in the main function like this, the code will still work correctly. The main point here is that it essentially doesn't matter what variable names you use when declaring functions. However, a good rule of thumb is to use self-explanatory identifiers, both for variables and functions. For example, the name checkPrime sort of gives you an idea as to what the function does. Alright, now remember, the for loop and the while loop are interchangeable, but in some cases one is preferred over the other. So the for loop is generally preferred for handling arrays, and that's what we're going to do in the next lesson. As usual, to test your grasp on the material covered in this video, you can take a quiz that you can find on our Patreon page. The link is in the description. If you have questions or need help with the material in general, you can schedule a one-on-one meeting with me. The link is also in the description. And of course, don't forget to like and subscribe if you haven't yet, and turn on the bell not to miss the next video. And I'll see you then. Bye.